Good day to everyone. My name is Siti Nur Ashikin binti Muhammad and my number matrix is CE210221. Today, our group will present the theoretical and the technical of time-varying field based on our project, which is a phone charger using the dynamo concept. An important idea in electromagnetism, time-varying field induce the dynamic behavior of electrical and magnetic fields. Time-varying fields are important in understanding the change of electric and magnetic fields over time. Michael Faraday's key discovery is that charging magnetic flux in a coil generates an electric force. These fields occur due to moving charge or charging electric currents. Using a wheel or cranks, our main goal is to make smartphones capable of charging. These fields occur due to moving charge or changing electric currents. For the DC motor parts, a DC motor field or coil or stator magnet is non-moving part which winding is wound to produce a magnetic field. Next, the armature is a rotating part that rotates on its axis. And the primary function of a commutator or a brushes is to supply electric current to the armature winding. These brushes conduct electric current from the external circuit to the rotating commutator. And then for the coil is to produce the strong magnetic field. Wrap coils of a wire around an iron cord. Current passing through the coil of wire magnetize the rod, producing a powerful magnet called an electromagnet. The more loops in the coil, the stronger the magnetic field.
Next, an electric motor is an electric machine that converts electrical energy into mechanical energy. The basic working principle of a DC motor is whenever a current carrying the conductor is placed in magnetic field, it experiences a mechanical force. The direction of this force is given by Fleming's right-hand rule. This video is an electric current supplied external through a commutator. The commutator reverses the current every half turn to ensure that the top rotates the coil in the same direction. When an electric current passes through a coil in a magnetic field, the magnetic force produces a torque that turns in the DC motor. Okay, this is the Fleming right-hand rules. So, look at the picture of Fleming right-hand rule on the left. It shows the direction of motion of conductor upward is up. If up, we need to strengthen the first finger, second finger, and thumb of our right hand so that they are perpendicular to each other. And the direction of the magnetic field is represented by the first finger. This is the magnetic field, and the direction of the current is represented by the second finger, and the direction of the current will flow to the left. This left. Then the mother of the finger represents the direction of the force experienced by the current carrying conductor. So this is the motion of conductor is up. So at the right picture, if the motion of the conductor is downward, so this is downward, is inter is the same concept is upward. So only the direction of the current will change and flow to the right. So this is the current and that flow to the right.
Okay. Assalamualaikum and a very good evening. My name is Muhammad Dishazal Muhammad Fiz and my metric number is CE 210135. So today I will explain about introduction using the poster for our assignment. So our title that be given is time varying field and our project name is Dynamo Phone Charger. So this is our group member. And for the introduction, for this time varying field, we know that Faraday law is a fundamental of electromagnetic field that show how the magnetic field, plug and induced voltage interact in a closed circuit. So for this project, we know we want to do a project about by using the DC motor itself to generate current by moving the coil inside the motor. So we have two, by moving the magnet and static the coil, or by static the magnet and moving the coil. So this DC motor, we know the magnet will be static and the coil will be moving. So for this project development in the static field, electric field and magnetic field are independent of each other. So static magnetic field are equal to the direct current of static magnetic charge, while the time varying are due to accelerated charge or time varying current. So this project is a charger phone by using the concept dynamo. So by the dynamo itself, we take from the bicycle that generate the bulb or lamp at the when the tire of the bicycle rotate, and we generate current to light up the lamp. So we use the concept from the dynamo itself, and the dynamo use the concept from Faraday law. So the mechanical power on an electric generator. So when you're using the dynamo, so when the dynamo moving, with the wheel from the bicycle moving, and then there will be some a gear at the dynamo itself will move when the tire move, the bicycle move, the gear will be moved. So inside the dynamo also will be moved. So we use a mechanical power, and then from the mechanical power will be converted into electrical power. So from that we know that is usually obtained from a rotating shaft. So will be a shaft inside the dynamo itself, and is equal to the shaft torque multiplied by the rotational or angular velocity. So using a wheel or crank. So our project is using the crank, and the concept from the bicycle itself for the dynamo is using a wheel. So our project main goal is to make a capable of charging smartphone. So our methodology itself, so when we start from the start, we connect the charger to the USB module. So the crank should be moved, and then the magnet bar inside the DC motor itself will be static, and then the shaft will be moving. So the coil will be located at the shaft, so it will rotate, and then will generate current itself. So when the more faster the shaft moving, or the faster the shaft moving, the more current will be generated. So when the charge is hard to make the crank become constant, we supply constant current because we're using our hand, right? So it's not enough to sometimes to charge the phone, and sometimes you cannot charge the phone because due to the not constant charging. So then we stop. So this is for the methodology. So this is our prototype and discussion. So this is our project figure. So this is the crank that will be used to move, and to move the gear the DC motor here. So this connect by using a rubber, more hardest rubber, so that it cannot break easily. So and then at the back will be connect to the USB module here, and then when we starting to move the crank clockwise, it will generate a positive current. And if we use anti-clockwise moving, when we move it anti-clockwise, it also generate current but negatively. So this project explore the time varying principle in magnetic field and inductor, focusing on the cutting of magnetic fields and the transfer of charge through induction. This experiment aims to understand the charge and their implementation in the implementation on phone charging, and also can light up a bulb, not a bulb that have more watt, but just a simple bulb to make it light up. So I think that's all from me. I will pass to the next presenter. Thank you very much.
Okay, continue for another part about problem statement. So what the problem that we have faced? First, all type of charger generated the slow current, and the another one is phone charger can be easily damaged when overloaded. And next, they are possible to become harm to user. And the last one is problem statement is overversion take the time to charge back the charger until full. So for the objective of our prototype of project is to improve the energy efficient and performance. So from that, user can optimize when use the charger phone without harm to self. So for the industry application for our project is first, electric energy is produced by generator using the mechanical energy. So from that, the function by rotating a coil in magnetic field, which is induce a current in the coil according to Faraday law of induction. So from that, power plant and wind farm both need together. So continue for the conclusion. What the conclusion we can get from our prototype is, first, the charging process utilize the energy more efficient and at faster speed. So compare the old vision of our phone chargers at this photo prototype analysis discussion. Compare with the another that we have made for fast charging for the phone is this is the fast charging phone we made for the prototype. We use the two motor to generate the more powerful current to charge the mobile phone or tablet. So from that, this is important to set project to the foundation of our future advancement in charging technology, ultimately leading to use more sustainable and convenient user without harm to the user. Okay, thank you. This is my part for problem statement and conclusion.
Hello, my name is Muhammad Mifan. My matrix number is CE210021. Today I want to explain about how my prototype works. So first of all, we use the motor, the crank and the USB port to charge the tablet, and another way we use the bulb. So next we work. First we connect the wire, then we move the crank to make sure the magnetic field will generate and the current will generate. Okay, 1 and 2. So from that we can see the tablet will charge. Okay, the another way is we use the bulb to confirmation the current have generate. So the bulb is light, and we can also see at the USB port the red LED will blinking. That means current will generate.
Okay, Assalamualaikum, a very good evening. My name is Muhammad Adi Shazwan Muhafiz and my matric number is CE210135. Okay, before this, my friend already explained about this project and show the project result. So today I will explain about next I will explain about how the project work actually using using Faraday law. So by looking at this, okay, this is the motor, the shaft inside the motor itself, inside this motor. So I take it out, So this is the coil itself, the coil for the motor. As we assume that the coil for the coil is almost 150 for each. So this is the iron for inside the motor. This is the shaft. So this is the way the current will be generated. So next, this is the housing. The housing will be inside this housing. So there is two magnets. So first the N and S. So we can assume that NS or SN. So inside this, the magnet inside. So this is where all the theory will be, all the work will be do inside this. So when the coil start to moving, so the current will be flow, because we know that in Faraday law, we use the magnetic field or the magnetic flux. We can assume that when there are two choices. So first, we need to move the magnet, or the coil is moving. So we choose the coil to move rather than the magnet. So we make the magnet be static and the coil will be moving in the center. So when the coil moving in the center, we know that the magnet will be the current will be generated in the center, and then will be flow through this, and will generate current, and will be give the supply to make the tap charge. So I think that's all from me. Thank you very much.
I am Venkat from Group 7. I will present about the conclusion. The charging process utilizes energy more effectively and at faster speed because of the time-variant field. This is important project set the foundation for the future advancement in charging technology, ultimately leading to a more sustainable and convenient user experience. Thank you.